Bonjour, baddies. Welcome back to another video. Today's first question is, draw a 5-pointed star like the one shown below. Find the sum of the measures of the angles at the 5 points of the star. I have already drawn which 5 points we are looking for. However, you could probably be able to find it by yourself anyway because it's just the points of the star. Alright, so if we look closely at our star shape here, you can see that there's this silly little pentagon-looking shape in the center. And if we are looking for the side angles, the point angles of our gorgeous star here, this pentagon might be able to come in handy, as it is sharing it does create 180 with a lot of the triangle's angles. And as you can see, when we highlight the pentagon, it splits the star into a single pentagon and 5 different triangles. So that's also pretty important. If we just look at our pentagon here, we can use our cool little formula in which n is our side length. So we're trying to find the interior angles of our pentagon because that seems like the only real numbers we can kind of get here. So n minus 2, n being the amount of sides our polygon has, multiplied by 180. Therefore, since it is 5, 5 minus 2 is equivalent to 3. So we have 3 times 180. And you might be like, oh, well, cool, but that doesn't really help me anywhere, does it? Okay, be patient. Another thing here is that, like I've said in a lot of previous problems, we don't actually need to find each point individually. We can just find them as a whole. So let's name our whole, well, sum. I know, it's very creative. So our sum, let me just scoot this to the side because this is going to be very, very long. Let's just write out our sum here, okay? Because if we look at our triangle, since each triangle's interior angle sum is equivalent to 180, this means that if we can find out these 2 silly little angles, we should be able to find out that one too, right? However, it is very hard to find out these angles, and it does not give us a very distinct answer. But we can still utilize these 2 answers by using 180 minus the 2 angles. So if we can name our angles here, since these 2 are equal and these 2 are equal as well, and so on, we only need 5 of them. So this is 1, this is 2, this is 2 as well, this is 3, 4, 5, and this is also 1. So using our formula, we can go 1 triangle at a time, starting from here, since I did start 1 from there as well. So using our formula, 180 minus angle 1 plus angle 2, which is equivalent to this angle. However, we do not know what angle 1 and angle 2 are yet, but that's okay. Plus 180. I'm going to scoot our drawing down a little bit so I can have space for my insanely long equations. For this problem, they are quite long due to the fact that there are a lot of numbers, or not really numbers, but more numerical angles. Minus angle 2 plus angle 3 plus 180 minus angle 3 plus angle 4 plus 180, just little gremlin. 80 minus angle 4 plus angle 5, and we're almost there. We just have one more. Just plus 180 minus angle 5 plus angle 1. So that's rather long. Probably one of the longer equations I've ever written, but it does get the job done. So our sum is also equivalent to, if we pull out the 180, since there are 5 of them, 80 degrees. And we can also pull out the 2 here because each of them seem to have 2 of them. So there's 1, and there's 1 at the very end. 2, 2, 3, 3, 4, 4, and so on, so on. So we can also pull out a 2 here. Angle 1 plus angle 2 plus angle 3, 3, plus angle 4 plus angle 5. And this is about as far as we can get with this equation. And notice how I said only this equation. We still have a way to solve this by following this path. And on a competition, you'd probably be pretty grateful for that too, because you just spent like 5 minutes writing this very long equation, and you're just like, oh my god, I can't even use it anymore. You still can. So, using the idea that since our pentagon, its interior angles add up to 540, we can write an equation based off of that. So 540, as you can see in our little triangle here, star-shaped triangle thing, each angle here of the pentagon, since it's on a straight line, that means that they add up to 180 together with each of said angles. As you can see, this, and this. And if we can utilize that fact to write in another equation in order to solve for our numbers, wouldn't that be great? Because we technically can. So we have 180 used again. So 180 degrees minus, and since it's the interior angles of the pentagon that add up to 540 and not the outer angles of the triangle, we are going to use minus angle 1, so like this bit, this bit, this bit, this bit, and this bit. And we're still using this idea that since 180 minus angle 1 is equivalent to one of the interior angles of the pentagon that share it with angle 1 that add up to 180. Therefore, this is also equivalent, and we have also been able to squeeze in all of our numerical angles. So 180 minus angle 2 plus 180 minus angle 3 plus, big workout, 180 minus angle 4 plus 180 minus angle 5. So now we have another insanely long equation. And now we can combine again to form a 180 times, there are 5 of them again, minus 1 plus 2 plus 3 plus 4 plus 5. And now, as you guys can see, 540, as we originally wrote, is 3 times 180. So if 3 times 180 is equivalent to 185 times 180, just so you guys can see the connection better, 1 plus 2 plus ... plus 5. This means that our interior, if we scoot this to the other side, this would be equivalent to negative 2 times 180, and this side would also be negative. But if we multiply by negative 1 before we do so to not waste time and write another equation, we'll just get 2 times 180 is equivalent to angle 1 plus angle 2 plus ... plus angle 5. So, now that we found out what our interior is equivalent to, we can plug it in to our original equation. So all the way up here. So now that we know that our interior here is equivalent to 2 times 180, we can write out another equation in which 5 times 180 degrees minus 2 times 180, now that we can plug it in. And originally, this was equivalent to our answer. So now that we have our answer-winning equation, we can just solve for it. If we put in this 2 into our equation, we're going to get 5 times 180 degrees minus 4 times 180, and 5 times 180s minus 4 times 180 is equivalent to 1 times 180, which is just 180 degrees. So this was probably a rather long question for you guys. In the end, though, it's just kind of a matter of knowing a good strategy in order to, set the whole thing up, or else you'd just be solving aimlessly, and I did not even get to expand that triangle properly. There we go. So this was basically a show your work, quote unquote, as my elementary school math teachers always used to say. And so yeah, that is the end of this video. Oh, that is a massive equations. And I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Bye-bye!